going to kind of combine what we learned in Chapter 8 with what we learned in Chapter 7 because we're going to go back and we're going to do some factoring. And I just want you to think about right now, if I told you that I'm thinking of two numbers, and when you multiply them together, the answer is 0.
1 and 0.
Okay, that's a possibility.
2 and 0.
Possibility.
1,000 and 0.
Okay,
4
so
and 0.
all of you are giving me a number, and you're giving me the number 0. So what are you saying?
Anything multiplied by 0?
0.
Anything multiplied by 0 is 0. You're telling me that one of the numbers has to be 0.
Yes.
Do we know which one?
Doesn't matter.
No. So in algebra, we call that the zero product property. Okay, the zero product property says that for all real numbers, A and B, so if I think of two numbers, we'll call one of them A and one of them B. If I multiply them together and get an answer of 0, then either the A has to equal 0 or the B has to equal 0. Okay, that's called the zero product property. So for starters today, they're going to give you some equations that are already factored. Okay, how do I know that this is already factored? Well, I see the parentheses. There's two binomials here. I'm not going to multiply them out. I'm going to leave them in their factored form because this quantity here is representing a number or a value like A, and this quantity is representing a value like B, and we're multiplying them together and we're saying it equals 0. So just using that zero product property, we're saying that either the x plus 7 has to equal 0 or the x minus 3 has to equal 0. One of them has to equal 0, I don't know which one, in order for their product to equal 0. So if it were the x plus 7 that equaled 0, when I solve that, I would subtract 7 from both sides of the equation, and I would get an answer of x equals negative 7. If I were to solve the other one, if it were the x minus 3 that equaled 0, I would have to add 3 to both sides of the equation, and x would equal 3. So I have two solutions to this. If either x is negative 7 and I plug that in here, or if x is positive 3 and I plugged that in there, I would get an answer of 0 when I multiply. Does that make sense? You're going to get two solutions. Okay, in the second example over here, it's already factored for me. I've got a 3 out here that doesn't contain a variable. Now, it would not make sense for me to say that that 3 equals 0. Because there's no variable involved, that's like taking the greatest common factor out. But since no variable was involved, we don't do anything with that in our solution. It does not affect my solution. But the quantities here, I'm going to have to say that the 2x minus 1 could equal 0. That represents a value, and it might be 0. Or the other factor, x plus 3, could be the one that equals 0. And I need to solve it. So in this first one, how would you solve for x? No. You've got to undo addition or subtraction first. You go back to first semester when we solved equations. We undo the subtraction first by adding. Then we divide. So 2x equals 1 Now I can divide by 2 and get an answer of 1/2. And in the second one, if I subtract 3 from both sides to get x by itself, x would equal -3. So here are my two solutions. If I were to plug a 1/2 into that equation for x, this first quantity I would get a 0 out of, and this would be 3.5, but 0 times 3.5 is still 0. And if I plug the -3 in, I would get a -7 out of this first group. But if I put the -3 in here, I would get 0. -7 times 0 is still 0. So you have two values that will produce a 0 in that equation. Okay, now those are already factored for you. And you're also going to see some quadratic equations. You'd write down example 3. It says solve each equation by factoring. In this particular example, this has not been factored for me. I don't see the parentheses, so I'm going to have to do that part. Okay, it's important that you have the equation set equal to 0. That's a must. So make sure if you have terms on both sides that you have them all on the same side. You have it set equal to 0. And now I have to take this and I have to factor it. So if we go back to chapter 7, you could make an x if that's how you chose to factor. Some of you might know what that is without doing the x. But if I use the x, I would use the coefficient of 1 times -8, and my middle term is a -2. So what factors, when I multiply, I'll get -8, but when I add, I get a -2.
Plus 2 and
Plus 2 and -4. So I would do x plus 2 and x minus 4 equals 0. Okay, all I've done is taken this polynomial and I've written it in its factored form. I haven't changed it. It still equals 0. And now I can say, all right, if this times this equals 0, I can use my zero product property to say, well, either the x plus 2 has to equal 0, or the x minus 4 has to equal 0. I solve each one. So here I would subtract 2 from both sides. And so x would be a -2 in that situation. Over here I would add 4. So I get x equals 4. So here are my two solutions. If I put either one of those values into that equation for the x, I'm going to get a 0. Those would be the two solutions. Make sense? And I'll just go back and tell you, when you use the x method, don't forget that I should have mentioned this, but sometimes you're going to have coefficients that aren't a 1 here. Let's see if I can get this to erase for me. But don't forget the step of dividing by the leading coefficient. It's just in that case it didn't change the values, but don't leave that step out when you factor. Okay, I want you to write down example 5. Write down example 5. And actually, it's missing something. What's it missing? Equal sign, yeah. So let's write this down. It should say equals 0, not plus 0. It should say equals 0.
special cases.
Okay, now this is a quadratic, but it's not a trinomial. But how do I factor that? What's the first step in factoring? Greatest common factor. Do these two terms have a greatest common factor?
Yes.
What do they have in common? x. So you got to make sure that you factor out an x. And then what would be left if I took an x out of each term? X plus 6. So factoring that, I don't have to make that x because there's a greatest common factor. And once I take that greatest common factor out, this is no longer factorable. I'm done. That's simplified.
Now we just gotta do the math.
Now you've got to apply the zero product property. You've got to say, okay, I've got two factors here. What if the first one, x, is equal to 0? Now there's nothing to solve there. It's already solved. X could equal 0. Or this x plus 6 could equal 0. And in that case, I'd have to subtract 6 from both sides. And I get x equals negative 6. So here would be my two solutions. Now remember on the previous example up here where the greatest common factor was just an integer, 3? We just left that out. When we take out the greatest common factor, if there's a variable with it, you've got to set it equal to 0. It's only if it's a constant that you do not need to set it equal to 0. Okay, and then number 6.
No,
What's wrong with that one?
it's equal to negative 20.
It's not equal to 0. You cannot do these until you have them set equal to 0. So I would start this problem by adding 20 to both sides of the equation. Because I want this to be 0. And it's a negative 20 to start with, so I'm going to add 20 to it. When you write your polynomial on the left, put it in standard form. So put the x squared first, put the 9x in the middle, then put the 20. You're going to help yourself out greatly if you would write this in standard form. Much easier to factor. Okay, from this step, I would factor this into two binomials. Without doing the x, does anybody know what the two factors would be?
No.
X and x, obviously, since x is the variable. What factors of 20 are going to give me 9 in the middle?
4 and 5.
4 and 5. And it doesn't matter what order you have them in. And now we have to add on to this. Now we're finding the solution. So we take each factor and we set it equal to 0.
Meaning it's term.
And you solve each one. So x could be equal to negative 4, or x could be equal to negative 5. Those would be my two solutions. If I were to substitute either of those values back into my equation, either here or here, if I did it here, I would get a value of 0.